Hello, this is Naireza Alvin, and I'm working with my angel Janet on reinforced deep Q knowledge distillation for credit risk prediction. So it's a model that is that assesses the likelihood of someone, basically someone who has applied for a loan, their likelihood to default. Simple terms, not to pay the borrowed money back. We're going to use knowledge distillation, deep Q learning, reinforcement learning, this model. So for this particular model, and can call it a project, this is the EDA for the exploratory data analysis of the dataset. The dataset was extracted from GitHub, and we're going to share the link to the source of the data set. Going straight to the exploratory data analysis, we're trying to analyze the data and maybe identify the outliers in the data sets and maybe get rid of them. Try as much as we can to clean the data, the missing values, and yes, and plot some illustrations of the data, the relationship between the features. We are studying about the data and trying to clean it. So going straight to the code for the EDA, at the start, we are trying to import the libraries that we are likely to need. The pandas library, we are importing it as PT, and it is for handling and manipulating data. Is posted in the data set. We are importing NumPy as NP. It is for performing numerical computations. And yes, we are importing Seaborn as SNS, and it is for data visualization, and it is for creating statistical plots, same as matplotlib. It is for providing flexibility for a wide variety of plots. And those are the libraries we are likely to need in this EDA. So in this cell here, we're trying to load the data set. It is downloaded already on GitHub. This cell is we are reading it. This is because this is the library. We are using pandas. This is the directory, sorry, and we are using pandas library. We are using its read CSV function to load the data set. The next cell, this is the data. We are trying to extract the top instances in the data set. As you can see, these are the first 5 instances in the data set of particular features that we have in our data set. And then this is the data tail. This tail function, it is showing the features at the bottom of the data set. Moving on, this is the describe function. It is showing it is particularly describing the data in the data set. It's the mean, the standard deviation, the minimum value, maximum value, different percentiles, as you can see, of all the features in the data set. Yes. So the shape, this in this cell, the shape function is trying to reveal the number of rows or examples or instances in the data set and the number of features. As you can see, we have 150,000 rows and 12 columns. Those are features. The data.columns, this cell is trying to show the features that we have in our data set, as you can see. Then the data.n unique function, it is showing the number of rows that have values that are unique. They are not duplicated. They are unique. Now, like for example, in series delinquency in 2 years, there are only two values that are unique, aren't repeated anywhere. The same applies to all other features. These are the features. These are their corresponding number of values that are not repeated anywhere in that particular feature. Here we are just printing the columns, the features, and it's going back here. This now function, the is now function, and we are summing the examples in different features that have missing values or null values in different features. As you can see, monthly income, we have this number of missing values or null values and number of dependents. Otherwise, other features, they don't have missing values. To clean the data set, we are decided to drop, instead of replacing with the means, since our data set has quite a number of instances, we decided to drop the instances with missing values. Yes, this is what this cell is doing. We are dropping the missing rows. We are dropping the rows with missing values in monthly income and number of dependents features. We sum again. We see we have dropped the rows that had missing values in monthly income and number of dependents. What our target in this data set, we have a feature that is serious delinquency in 2 years. This is showing people who have defaulted in 2 years. Particularly, it shows people who have defaulted. They have missed their payment deadline by 30 days. And if this has happened in 2 years, these are the people, the categories of people who fall under this feature, and it's our target. The categories two, it can be yes or no. I mean, someone has a delinquency or they don't. If they have, that is symbolized by 1, and if they don't, symbolized by 0. It's what we are targeting, and here we are trying to illustrate it, and reveal it in percentages. So this is the new variable total length. This is the length of the data in this under this particular feature. Here we are trying to calculate, you count the appearances of each category, and then create, bring it out as a percentage. This is the output of this cell, and after getting the percentage, we are trying to show it as to illustrate it as a histogram. Yes. We are plotting it. So this is the cell that does the logic for the histogram. Using the seaborn, using the set function of the seaborn library to set the style, and then the total length is a new variable, and it is measuring the length of all the data in this feature. Since it's what we are representing in the histogram. We are setting that we go ahead and set the title for the histogram, its font size, the height, and whatnot, and also the decimal values. We round off to 2 decimal values, and also the font size, and we go ahead and center these digits, the percentages on the top of the bars. That's what's going on here. And then we set the labels. Yes, of the histogram. And then we plot it. So I'll let my colleague to pick it up from here. Yes.
Hello, everyone. My name is Mango Janet, and I'll take you through the rest of the EDA. So, the next part, we'll feature the scatter plot just to show the relationship between these two features, number of dependents and monthly income. And that's just setting up how to look like the size, SNS.scatter plot, identify the features X and Y, which already declared here as number of dependents and monthly income. So this is the scatter plot. So it just shows that the people in the data set that have low incomes have a small number of dependents, as you can see, monthly income and dependents, and most of the data is kind of this side. We have some outliers, like that one and this one. Yeah, just to show the relationship. Next, we wanted to get like the relationship between all features, like amongst all features in the data set, and we use the correlation matrix. We also use the heat map to show like what is really going on between these features. So here we have the correlation matrix sigma. And what you can see here is that the red shows like a very high correlation. As you go down, the correlation reduces like according to the colors. And what we looked at most was the red, because we don't want features to have like a very high correlation between each other. We just want one. So that means we have to eliminate the other. So if we go and look at number of dependents, it's high current, it's correlating highly to itself, so that's normal. So we have this 0.98 here with number of times 6 to 89 days past due and number of times 30 to 59 days past due. So since they are correlating, we have to decide which one we take out. We have more high correlations here, here, and here, over. So you just have to decide which feature you're taking out and which one stays. So we drop the number of times 60 to 89 days. Yeah, because there's a high correlation with other features. So next we went into dealing with outliers. First we created a box plot for number of dependents. That's the feature. And this is what it looks like. And you can see clearly that we have some outliers. So next on, we went on to like detect like the outliers. We used the interquartile range method where we calculated the lower quartile Q1 and upper quartile Q3, and we put the interquartile range where you get the upper minus the lower quartile. So here it's just printing them out. We got 0, 2, and 2. 0, lower quartile, upper quartile 2, and interquartile range of course 2. So after that, we went on and like calculated the upper, lower limit. We need to know the range. Where we just the quartile plus 1.5 times the quartile range. And this is what we got for the limits, lower and upper. So here, this cell just identifies like where are the outliers and prints them out. And these are the ones. We have 2, 3, 2 columns and rows and 10 columns. So we went on to deal on how we could remove them. And we just created a new variable, new data, and we got this cell. We just interchange like everything that's here. Like if this is greater, you make it less. This is a or, less with an and this you make it like greater, such that you can get the range of the data that you want to stay with, and you can eliminate the outliers because they will be out of this range because they would have to go out. So we just printed before removing outliers, after removing, and how many outliers we have, just subtracting the length of the old data and the new data. Yeah, so after that, removing them, we went ahead and plotted again to see like how is it looking like, and I think it looks fine depending on the first one. This one it's within the range because the upper limit was like 5, and yeah, so basically that's it. I think that will be like the end of the description of our EDA. Yeah, thank you for watching.